Ladies and gentlemen, welcome again. Been a little minute. I'm back. FrazierNation.com, Frazier Nation Entertainment. We out here geometry series. I come with you today. Let's walk hand in hand and learn about 2.5 and 2.6. Kill two sections with one stone. We're going to prove statements about segments and angles, and we're going to use algebraic properties. There's two objectives that I need you to be able to do at the end of this lesson. Students will be able to use algebraic properties in logical arguments, and students will be able to write proofs using geometric theorems. So the one essential question I want you to grab a hold of is, how do you write a geometric proof? Okay, we're going to go through that. I really like the two-column proof myself, kind of partial to that. This is something that you might need a little bit of help in because we're getting more abstract in geometry. So watch out for some more videos about that. A couple things I want you to remember, and I should have put this in 2.4, but we're going to put it here now. The segment addition postulate, okay, that was chapter 1. It wasn't explicitly brought to you in 2.4, so I wanted to put it in now. The segment addition postulate is where you add two segments to get a bigger segment, and angle addition postulate where you add two smaller angles to get a bigger angle. Okay, I need you to have those memorized, okay, along with postulates 5 through 11. We're going to go ahead and move through. Most of us have these notes already, but if not, let's go ahead. You can also get your guided practice so you can get full credit for your notes. Key vocabulary, there's 3 key vocab terms that I want you to get familiar with. Proof. Proof is a logical argument that shows a statement is true. A two-column proof, which is what I'm partial to, you have numbered statements and corresponding reason to show an argument in a logical way. Basically what this is saying is you're going to go step by step to prove something, and you need a reason for each step. Okay, so if step 1 is you added on both sides, then the reason for it would have been addition, property of equality. Okay, you'll see how that works in the guided practice. In the theorem, a theorem is a statement that can be proven. That's opposite of a postulate which cannot be proven. A theorem can be proven. So, next card. I want you to write this stuff down. This is stuff that we already know from Algebra 1, but that we're going to use in geometry. We kind of need this. And we bring this forth because this is something that you've used day in and day out for Algebra 1 and, you know, quite possibly pre-algebra if you had that at an earlier grade. Addition, property of equality, subtraction, property of equality, multiplication, property of equality, division, property of equality. So basically it's if you add on both sides, subtract on both sides, multiply on both sides, or divide on both sides. Another one that students kind of forget, but it's also really important, is the substitution property of equality. So if A equals B, then A can be substituted for B in any equation or expression. So let's say, for example, I have, and you guys don't have to write this down over here. Let's call it as optional. If I had 2x squared plus 3x plus 1, and I tell you that x equals 1, well, this is the substitution property of equality because instead of x, I can rewrite this and use the substitution property of equality to say, hey, 2, and then put a 1 squared plus 3, put a 1 plus 1. This is an example of the substitution property of equality because, hey, instead of A, I wrote B. So instead of X, I wrote 1. Next card. Distributive property is not of equality because it's not on both sides of the equal sign. So it's just distributive property. And this is where you multiply both terms or you distribute your front term. So you get A times B and A times C, which is right here. And 3 other properties. The main thing right here the main thing that you have to remember is reflexive property of equality. So reflexive, remember in the mirror, like it got to look the same on both sides. Symmetric property of equality is when you flip stuff around. Okay, so if A equals B, B equals A. And then transitive property of equality, if you have two things equal to a third thing, then that first equals the third. So if A equals B, B equals C, then A equals C. Okay? And then this stuff right here, we can call that optional. I would write this down if I was you. But, you know, whatever. This purple stuff, again, optional. And it seems like I can't write on my little pad tonight. And then the purple stuff here is optional. Okay? So you need this, and you need this, and everything else will be optional to you. All right, so here's some guided practice for you. I'm going to try to just drive through this. If we need to add some more numbers, we're going to add some numbers. So this is a 2-column proof right here. So let's say 2-column proof. Okay, where you have your statements, and let's put statements over here. And let's put reasons over here. Okay, you need a reason for each step. Okay, so I want to solve the equation and write a reason for each step. 4x plus 9 equals negative 3x plus 2. You can say that that's the first step because they gave it to you. Okay, in a geometric proof, traditionally your first step is going to be given. Okay, so how do I solve here? Well, you got to combine like terms, and I want to combine 4x and negative 3x. So let's put a little mini 3x here so that way you know where it's coming from. And let's put a little mini 3x right here. Okay, so 4x and 3x is 7x plus 9 equals 2. And why were you able to do that? Okay, you need a reason for that. Well, you are able to do that because of the addition property of equality. What did I do? I had to add 3x over here and I had to add 3x over here. Property of equality means on both sides. So right here, your reason would be the addition property of equality. Okay? Again, we're solving. So we're going to put a little mini negative 9 here and negative 9 here. So the third step is going to be 7x equals negative 7. Okay. So what did I do? I had to subtract 9 on both sides. So this would be the subtraction. I would put sub, but I have to put subtract. Subtract POE. Okay, because I had to subtract on both sides. And then finally, if I divide both sides by 7, x is going to be equal to negative 1. Okay, and that's because of the divide property of equality, division property of equality. Okay, so right here, like I said, and let's go ahead and just type this bad boy out. Remember I told you traditionally it's going to be the same, that first step. So the first step here is going to be given. Okay, so what do we do here? We took and we have to distribute my 3 right here. So this is going to be 14x plus 21, because 3 times 7 is 21, minus 3x equals negative 1. Okay, so what did you do here? And that's why I didn't want to do that. This is going to be distributive property. Okay, that's your reason. Okay, remember we had this early in our notes. We're probably gonna need a fifth number here. Jeez Louisa. Okay, let's move this stuff up. Let's go ahead. I gotta adjust some things real quick. All right, so, and actually we did not need to do that. Okay, hold on. Okay, so yeah, let's go ahead and do that. Okay, so let's delete this stuff. Okay, because I feel like we're gonna need some more room. Okay, now what do? It's not on both sides of the equal sign. Okay, we're just combining like terms. Okay, so the only thing we're gonna do, this is 11x plus 21 equals -1. Okay, and your reason here is gonna be combined like terms. Okay. Yeah, we're gonna need a fifth step. Okay, so number 4, we still have to add like terms. So I have 21 and -1. This is already positive, so it needs to be negative. So I have 11x equals -22, and that is because of the subtraction property of equality. And then number 5, x is going to be equal to -2, and that is going to be because why, people? Why? Because of the divide property of equality. So as you see in the 2-column proof, you need a reason, a logical reason for each step in algebra problems, or a good way to introduce that topic. Next, same thing. This is algebra still. I'm going to try to write this out. So the first step, I want to solve for b, so I want to isolate b in case you didn't remember that. So isolate, and I'm sure you had to do this in algebra 1. You need to isolate b. So I have a equals 1/2 bh. Okay, and this is given. Okay. So right here, what's going on here? I have 1/2 times b times h. Okay. The first thing we want to do is we want to get rid of this fraction. So if we have divide by 2, then we're going to multiply by 2 on both sides to cancel that out. So let's put a little mini times 2 here and a little mini times 2 here. So the next step is going to be 2a. The fractions here are going to cancel, and then it's going to be equal to bh. Okay, and what did I do? Multiply 2 on both sides of the equal sign. So this is multiplication property of equality. So I'm going to say multiply POE. Okay. And then next, and this is the final step, so we don't need step 4 for real. Instead of multiply, we got to divide both sides by h. So this would be 2a divided by h equals b. Okay, because what am I supposed to do? I want to isolate b. B is by itself. And so this is called the divide property of equality. Okay. So again, 2-column proof. And for every step, I need a reason for it. Next, let's see. Let's give you a little bit of time. If you go back to your notes, as we look at number 4, it says if measure of angle 6 is equal to measure of angle 7, Then measure angle 7 equals the measure of angle 6. So remember I told you, we have reflective, we have flip, and we have kind of the 1, 2, 3, the train line. So what happens here, number 4, we flip. And you have memorized that when you flip, so instead of 6 and 7, you got 7 and 6, you have the symmetric property of equality. Okay. Right here, so if JK equals KL and K equals 12, then JK equals 12. So if I have A and B, and I have B and C, then I have A and C. So what's going on here, we have kind of the 1 and 2, the 2 and 3, so 1 and 3. So this has to be the transitive property. And then on both sides of the equal sign, they look alike. It's like they're looking in the mirror. So I'm going to say mirror. Okay. And of course, what does a mirror do? It reflects. So number 6 is the reflexive property of equality. Okay. Make sure you have this written down. Next card. I'm going to go ahead and give you a couple of minutes, a couple of seconds to write this out. I know it's a lot, but it kind of illustrates what you need for your homework. You have 4 steps of a proof are shown. Give the reason for the last 2 steps. This is what the test is going to look like. You're going to have this, and you're going to want to know what these reasons are. So I'm going to try to point these out to you. So I'll give you a couple of seconds to write that down. Okay, so first and foremost, remember I told you traditionally it's going to be the given. Okay, now I want to point this out. Prove is never going to be a reason. Okay, this is the step that we want to get to. That's how a geometric proof is traditionally done. You start here and you keep going until you can get to this step. I'm not going to make it that hard where it's like a blank proof. You know, it'd be more fill in the blank, but I want to say prove is never a reason. Okay. So let's see. Why can I say AC equals AB plus AB? I give that to you. Okay. So that's given. That's given. Let's kind of do a little arrow right here. Be real obvious about it. Let's see. AB plus BC equals AC. Look at your picture. AB plus BC equals AC. So 2 smaller sticks. So 2 sticks equal the big stick. Okay, and that's what I told you segment addition postulate is. Okay, so that's why you have segment addition postulate as your number 2 step. Now, you got to see what the difference is. What's going on between step 2 and step 3? What's changing? Okay, so we're saying that AB, AB, and BC, AB are together. Okay, so hopefully you can see that AB plus BC equals AC. Okay, and we know that AB plus BC is equal to AB, AB. So we have AC and AB plus AB being together. So, oh God, I hope y'all can see that. So, can you see it? Okay. If you can't see it, I'll write it out. So, if I have A equals B, and I have B equals C. Well, actually, no, I screwed that up. I screwed that up. Y'all bad. Y'all bad. My fault. My fault. Okay, so if I have A equals B, and I have B equals C. So look, so what's the same? The B is traditionally going to be the same term. So if I have A equal B and I have B equal C, then I'm saying that A is equal to C. What property is that? Oh, you figured it out. It's the transitive property. Okay. And then what's changing from step 3 to step 4? Well, what's AB plus AB? And what's AB plus BC? Do you see it? Do you see it? What happened? What could you do? What could you do? Something happens. Okay, well, if you can't see it, what's the change from step 3 to step 4? Well, we cut this out and we cut this out. Okay, because BC is here and then AB is AB. So how do you get rid of a positive something? What's the opposite of a plus? Negative. So that means that I subtracted AB and AB. So this is the subtraction property of equality. Okay. Lastly, again, what's going on in number 2? Well, if I have something equal to itself, that's a mirror. And what does a mirror do? It reflects. So number 2 has to be the reflexive property of congruence. I would have took the equality either way it goes. And then right here, if I have the same equation, we just flipped it. So if I say flip, then we know that number 3 has to be the symmetric property of congruence. Okay, so let's think about some things that we did. 2-column proof. Okay, that's really the most important thing here. Okay. You have statements, reasons, statements, reasons, statements, reasons, statement, reasons. I would get more comfortable with my algebraic properties. Okay. I'm not really putting too much emphasis on them because, like I said, you use them day in and day out in Algebra 1. But anyway, you know how I do it. These are exciting times. T. Frazier, we out here.